Hello class, welcome to this video on probability statistics, lesson 2.1 to 2.3 quiz. So we're going to go over one of the versions of the quiz, so hopefully you find this useful. Alright, so it says in 1798, English scientist Henry Cavendish measured the density of the Earth several times by careful work with a torch and balance. The variable recorded was the density of the Earth as a multiple of the density of water. Here are the 29 measurements, the dot plot, and the numerical summaries. So this data only gives you 21 of the measurements, so I'm not sure what happened to the other measurements, but we got all of the measurements here for the density of the Earth in the dot plot, okay? So remember, to calculate the percentile, it says find the percentile for the dot, which represents a measurement of 5.75. So we need for 5.75 less than or equal to that value. Okay, so the percentile is the number of values less than or equal to, in this case 5.75, divided by the total and times 100. Okay, so we're going to do that. We're going to do just that. So 5.75 is right here. That's 5.75, and we want everything to the left of that. Okay, so we're going to count all of these dots. Now, they said that there are 29 measurements, and there's only 2 that are above, which means we have 27 measurements that are equal to 5.75 or less than. Okay, so we got 27 out of 29 measurements times 100. And we'll calculate that as a percentile. So that's 93.1. So it's approximately the 93rd percentile. Okay, so that's 5.75. Now interpret the percentile. So what this is saying is that the 93% of the measurements were less than or equal to 5.75. All right, so that's the interpretation of the percentile. Now calculate the z-score for the measurement of 5.5. All right, so to calculate the z-score, we take the x value minus the mean. In this case, the mean is 5.448 divided by the standard deviation. All right, so the 5.5 is my x value, right? So we got 5.5 minus the mean is 5.448 divided by the standard deviation, 0.221. Okay, so we calculate that and we round it to 2 decimal places. See what we get. Okay, so we got 0.24, so approximately rounding that, okay? And that's my z-score. And now we want to interpret the z-score. Okay, so this means the number of standard deviations, 0.24. So that means we're 0.24 standard deviations above the mean. So that's how you interpret the z-score, is that it tells you the number of standard deviations above or below the mean. Okay, so we're going to say the measurement of 5.5 is 0.24 standard deviations above or greater than the mean. Okay. All right. Find the measurement which is at approximately the 70th percentile. So that means 70th percentile is 70%, which we convert to 0.70, right? So we need to do 0.70 times the total, which was 29 measurements. Okay, so we're going to do 0.29 times 7, so I'm going to do that real quick. I'll just do it over here. So that's 20.3. So approximately the 20th, approximately 20. So we need to look for the approximately the 20th measurement, right? So we're going to need to do just that. So we're going to use a dot plot again for that. So we got 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that means there's 20 here. There's a total of 29 measurements. So if I trim the top 9, then it gives me the from left to right, that's about 20 measurements, okay? So that means the 20th measurement is this dot right here, and that dot is at about 5.59, okay? So it looks like it's about 5.59. So let me just focus on that dot right here. So this is the dot. So this is 5. Yeah, so that's about 5.58. Okay, so this is about 5.67 or 5.567. So around 5.58 or 5.59. So either one would be fine. So if you said either one of those, I would take it. So so the measurement of 5.8 or 5.58, sorry, or you could say 5.59, around there, is at approximately the 70th percentile. Okay. All right, so either one of those is fine. So now, number 2, when Sam goes to a restaurant, he always tips the server $2 plus 15% of the cost of the meal. Sam's distribution of meal costs has a mean of $9 and a standard deviation of $3. Find the mean of his distribution of tip amount. Okay, so this is a transformation question. It says that the mean is $9, right? And it says he tips $2 plus 15% of the cost, right? So, okay, so this is a transformation. We're taking the mean and we're the distribution of meal cost, and we're transforming it into the distribution of tip amount. The mean is affected by both addition and multiplication. So we're going to take the mean, which is the X bar, and we're going to take the sorry, I'm going to use mu for the mean. So the mu or the mean is going to be the $9 times 15% of the cost. So that means 0.85 or 1.15. So 1.15. All right, so that's 15% of the cost, so it's a 15% increase. So it's 1.15 plus $2. All right, and so we'll do the calculation, see what we get. So you get about $12.35. Okay, so that's the mean of the new distribution. And then we're going to do the standard deviation of the new distribution. It says standard deviation was $3. Now, the standard deviation is variability. Variability is affected by multiplication and division, but it's not affected by addition or subtraction. So we're not going to actually add the $2 into it. We're just going to do the multiplication part, okay? So we're just simply going to do 1.15 times the standard deviation. So the standard deviation was 3. So we're going to do the $3 times 1.15. Okay, and we're not going to add 2 to that. All right, so it's going to be $3.45. That's going to be the standard deviation of the new distribution. All right, and that's it for that question. You just have to understand that variability gets affected by multiplication, division, addition, subtraction, affects the center, the mean, and all that stuff, and multiplication affects the mean. An internet reaction time test asks subjects to click their mouse button as soon as a light flashes on the screen. The light is programmed to go on at randomly selected time from 2 to 5 seconds after the subject clicks start. The data can be modeled by a uniform distribution. Draw a density curve to model the amount of time the subject has to wait for the light to flash. Label the x-axis and include the scale for the x-axis. Determine the height of your density curve. Okay, so draw a density curve. So we want to, so we know that it's going from 2 to 5 seconds. And this is the time to flash, right? The time for the light to flash in seconds. And it says it's a uniform distribution, so it's going to be a flat curve from 2 to 5. These are just dashes here. And we need to find the height of this curve. So the height of the curve, remember the area of a density curve has to be 1, right? And the area for a rectangle is base times height, and we know that the area has to be 1. So I'm going to say, okay, well 1 is equal to the base is 3. From 2 to 5 seconds, that's 3 seconds. So it's 5 minus 2 seconds times the height, which we're looking for. And so we get 1 is equal to 3h. So if we divide by 3, the height has to be 1/3, right? So this has to be 1/3. And there is your density curve, which is the area equal to 1. Now for part B, about what proportion of the time will the light turn on between 2.5 and 4 seconds after the subject clicks start? So between 2.5 and 4 seconds. So we want this area right here. So we have to calculate that area. So the area of that red portion is from the base times height, right? The base is 4 minus 2.5, and the height is 1/3. So we get 1.5 times 1/3. Okay, we'll do that on the calculator. So you get 0.5. Okay, which is 50%. So 50% of the time the light will turn on between those 2 times. All right. All right, so now find the first quartile of the distribution. So now the first quartile is the 25th percentile, right? The second quartile is the 50th, and so on and so forth. So we want to find the 25th percentile. So basically we want, and I'll draw a different curve. So we want to figure out, okay, so what's the x value so that such that the area to the left of that is 0.25 or 25%, right? So 0.25. Okay, so that's what we want to find. We want the area to the left of that to be 0.25. So the area of this blue rectangle has to be 0.25, and we find it by doing base times height. So the base here is x minus 2. Whatever the x value is, minus a 2 gives me my base. And my height, remember my height was 1/3, right? So it's the x minus 2 times 1/3. Okay, and that's what we got. And so now we got to solve it. So we got to distribute the 1/3. So we got 0.25 equals 1/3 x minus 2/3. Actually, what I'm going to do is I'm going to get rid of the 1/3. Instead of distributing it, I'm going to get rid of the 1/3, and I'm going to multiply by 3 on both sides, and that's going to cancel this out. Okay. So multiply by 3 on both sides, and this is 0.75 equals x minus 2. And then we can add 2 to both sides. And we get x is equal to 2.75. So this is my 2.575 seconds is my 25th percentile. Okay. Okay. All right. So there's your answer. That's really the quiz, guys. That's all you needed to do. So now let's do the bonus question and show you how to do the bonus in case you're interested in that. But you also want to include this as part of your notes for your assignment, the bonus question as well. Okay, even though it's not part of the quiz, it's an extra question. Suppose the number of accidents is not equally likely a certain distance from a city. From 0 to 8 miles, and is modeled by the following density curve. Okay, following curve. It's not a density curve yet, by the following curve. What should the peak of this height of this graph be to make it a density function? So we need to figure out what the height should be, right? Remember that the area has to be equal to 1. Now this is a triangle, so the area is 1/2 base times height, right? And that's the area of a triangle. And all right, so we need the area to be 1. So 1 is equal to 1/2. Now the base here is 8, right? And then we need to figure out the height. So 1/2 times 8 times height, which is equal to half of 8 is 4. So 4h. So then divide by 4 on both sides. And h is equal to 1/4. All right, so there's my height. It's 1/4. All right, so at least if you knew how to do that part, I mean, you get extra point there. Find the median of the density function. All right, so the median is the 50th percentile, right? So we need the area to be 0.50. So we need to figure out, okay, where is this value located? We don't know where it is yet, such that 50% of the curve is to the left or to the right, either one. And so what you could do to make this a little bit easier is just look at the area on the right side, because that's a triangle, right? And we can do a triangle easier than we would do it. For example, on the left side, we got a trapezoid, right? So it's easier to do a triangle than it is to do a trapezoid. So let's go ahead and do the triangle just to make it a little easier. So either way, this has to be 0.50, right, on either side. And so let's get the area. The area has to be 0.50, but then we know that the area of a triangle is 1/2 base times height. Now the base of this triangle is 8 minus x, right? So it's the 8 minus wherever the x is located. So if x is 3, then 8 minus 3 is 5, right? So it's 8 minus x, so that's my base, times my height. What's the height of the triangle? The height of the triangle is, this point right here, from here to here. But how do I get that? Well, I need to, in order to get the height of the triangle, I need to figure out what this function is. So I need to use a little bit of algebra, okay? So y equals mx plus b, right? So what's the slope of this graph? So the slope is m, right? So let's just do it here. The slope is going down 1/4 and then over 8. So down 1/4 and over 8, so it's negative. So down 1/4 and over 8, that's negative 1/32. Just do 4 times 8 is 32. So there's your slope. And then the b, well, we know that b is where it crosses the y-axis, right, which is at 1/4. So plus 1/4. This is my b, right? There's my equation. And so my height is given by this equation, okay? So that's the height at x, okay? All right, so we got 1/2 base times height. Let me go back to the problem here. So we said it was negative 1/32x plus 1/4. All right, and I'm going to rewrite this as 1/4 minus 1/32x. Because I like the positive number to be first, and then we're just going to switch the positions. Okay, there's your equation. All right, so 1/4 minus 1/32x. All right, so there's our equation. So now what I'm going to do is I'm going to get rid of this 2. So I'm going to multiply both sides by 2. And that turns that into 1, right? the next thing I'm going to do is I'm going to get rid of this fraction here. I'm going to get rid of this guy here because I don't want that there. So I'm going to multiply both sides by 32, and that's going to cancel this, right? But then I still got to distribute it to that. So 32 divided by 4 is 8, right? So this turns into 8. But on the left side, we got 32. Okay, so 32 equals 8 minus x times, and then 32 times 1/4 is 8. And we got minus x. Oh, look at that there. So we actually got 8 minus x times 8 minus x. That's interesting because it's the same thing, right? 8 minus x times 8 minus x is 32. So we can actually simplify. We can actually say that this is the same thing as 32 is equal to 8 minus x to the second power. All right, so now we can solve it. We could take this. The only way to solve this is one way to solve it is to take the square root. That's the only way to get rid of the squared, right? Is take the square root of both sides. When we take the square root, remember we had to do the plus or minus version. So take the plus or negative square root. So this cancels. And so we get plus or minus square root of 32 equals 8 minus x. And then there's no more squared. And so let's solve for x. I'm gonna solve for x here. I'm gonna move the x over to the left-hand side, and then I'm gonna move the square root of 32 to the other side. So I'm gonna move this here, and I'm gonna move x here. To move x, I gotta add it. To move this, I gotta subtract it and add it. So we get 8 plus or minus square root of 32. All right, so there we go. So now we just got to do this on a calculator and see what we get. So if I did 8 plus the square root of 32, I get 13.65. Now I'm going to do 8 minus the square root of 32. Oops. And I get 2.34 seconds. So, or 2.34 miles, sorry. Now, it doesn't make sense for it to be 13.65 miles because we only got from 0 to 8 miles, right? So that doesn't make any sense. So we can actually get rid of this answer and use this answer, okay? 2.34 miles, okay, so that's right around where I labeled it. That's between the 2 and the 3, right? So that has to be it, okay? So the answer is 2.34. So the median is approximately 2.34. All right, there you go. All right, and then so what proportion of accidents occur from 3 to 4 miles from the area? Okay, so now we're going to take this curve, which I'll just redraw it. This is 1/4. From 0 to 8, and then it says from 3 to 4 miles. Okay, so from 3 to 4 miles, we want this shaded region, right? Okay. All right, so we want that shaded region, 3 to 4 miles from the area. Now, this is a trapezoid. In fact, what I'm going to do is I'm going to make this a little bit bigger. I'm going to put 4 over here just to make the trapezoid look a little bigger. Okay, so we want to focus on that area. So now the area of a trapezoid is 1/2 times the height times base 1 plus base 2. All right, the bases are given by the parallel sides. So this is base 1, this is base 2. Let me use colors here. Base 2, base 1. This is the height of the trapezoid, and that's all you need. All right, so the area of the trapezoid is 1/2 times the height is from 3 to 4, right? So it's just 1, but I'm just going to show my work. The height is 4 minus 3. And the base 1. Now, the base, you have to find the base using the equation. Remember, the equation is y equals What did we write it down? What it was? We wrote down 1/4 minus 1/32x. That was the equation. And so in order to get B1, we had to plug in 3 into that, okay? So I'm just going to do that here. We get 1/4 minus 3/32, and we got to combine those fractions together, or you could just do it as a decimal, but we're just going to do a little bit of fraction math. 1/4, we're going to times 8 top and bottom, so that's going to be 8/32 minus 3/32 is 5/32. So that's my B1, is 5/32. And now we're going to do B2, which is 1/4 minus 1/32. Now the x value for that is 4. So we get 1/4 minus 4/32. And 4/32 is the same thing as 1/8. And 1/4 is the same thing as 2/8. So 2/8 minus 1/8 is 1/8. Okay, so we got 1/8 here. But we might as well convert it into in terms of 32. So I'm just going to leave it as 4/32 times 4 top and bottom because we got to combine it with the 5/32 anyways, right? So I might as well just leave it in terms of that. Okay, so we get 1/2 times 1 times 9/32, 5 plus 4. And so we get 9/64 is my area. Okay, 9/64 is about 0.1406. So that's 14.06%. So about 14.06% of accidents occur from 3 to 4 miles from the area. All right, guys, there's your bonus question. That's going to do it for the video, guys. I hope you found this useful and informative. As usual, I'll see you in the next one.